Why is the color of our oceans changing? And this will have an effect on land and has scientists worried. What's causing these changes? In the past, the seas and especially the oceans may have been scary for sailors and their ships, but now things are getting worse. The color of the oceans, which according to scientists is changing at such a rapid rate, will acquire completely different shades by the end of our century. So, what happens and what's causing this? Perhaps, say we don't care, we live on land, swim in the shallows, or do not get very far from the beach, but things are not that simple. Rising sea levels, warmer aquatic temperatures, the gradual extinction of phytoplankton and algae, along with many other declining or emerging conditions, are different pieces of the same environmental puzzle that begin and threaten the ecosystem and extension to ourselves. By the extension to ourselves, we are threatened as well. Since about 3/4 of the Earth's surface is covered by water, these consequences do not bring good news for the future of the inhabitants of the world and the islands. One of those changes that we can gradually see is a strong sign that something is wrong, and that would be the color, the changes in colors of the oceans and our seas. Kindly support my Patreon account since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. But given the terrifying effects on life on this planet, color is obviously the least environmental changes we should be concerned about. All these problems will be transferred gradually and onto the land. Just think of the fact that the seas and oceans fill the atmosphere with a huge amount of oxygen. And we have videos explaining various reasons why all this is happening, leading to a central cause called climate change. And there are a number of solutions to how this trend can be reversed, and they concern all of us, but also each one individually. There's recently been a study by MIT. Much of the surface ocean will shift in color by the end of the 21st century. Climate-driven changes in phytoplankton communities will intensify, and the blue and green regions of they will intensify the blue and green regions of the world's oceans. It's caused by climate change, significant changes to phytoplankton in the world's oceans. The new MIT study finds that over the coming decades, these changes will affect the ocean's color, intensifying its blue regions and its green ones, and satellites should detect these changes in hue, providing early warning of wide-scale changes to marine ecosystems. The article was in Nature Communications, and researchers reported that they have developed a global model that simulates the growth and interaction of different species of phytoplankton, or algae as we know it, and how the mix of species in various locations will change as temperatures rise in the world. The researchers also simulated the way phytoplankton absorb and reflect light, and how the ocean's color changes as global warming affects the makeup of phytoplankton communities. The researchers ran the model through the end of the 21st century, and they found that by the year 2100, more than 50% of the world's oceans will shift in color due to climate change. And that's, of course, terrible news. The study suggests that blue regions such as the subtropics will become even more blue, reflecting even less phytoplankton and life in general in those waters compared with today. Some regions that are greener today, such as near the poles, may turn even deeper green as warmer temperatures brew up larger blooms of more diverse phytoplankton. The model suggests that changes won't appear huge to the naked eye, and the ocean will still look like it has blue regions in the subtropics and greener regions near the equator and poles. This is what the lead author Stephanie Dutkiewicz explains. She was principal research scientist at MIT's Department of Earth, Atmospheric and Planetary Sciences, and the Joint Program of the science and policy of global change. And she said that basic patterns will still be there, but it'll be enough different that it will affect the rest of the food web that phytoplankton supports. Now, chlorophyll count. The ocean's color depends on how sunlight interacts with whatever is in the water. Water molecules alone absorb almost all sunlight except for the blue part of the spectrum, which is reflected back out. Hence, relatively barren open ocean regions appear as deep blue from space. If there are any organisms in the ocean, they can absorb and reflect different wavelengths of light depending on their individual properties. Phytoplankton, for instance, contain chlorophyll, a pigment which absorbs mostly the blue portions of sunlight to produce carbon for photosynthesis and less in the green portions. And as a result, more green light is reflected back out of the ocean, giving algae-rich regions a greenish hue. Since the late 1990s, satellites have taken continuous measurements of the ocean's color, and scientists use measurements to derive the amount of chlorophyll by the extension phytoplankton in a given ocean region. But Dukeshewitz says the chlorophyll does not necessarily reflect the sensitive signal of climate change. Any significant swing in chlorophyll could very well be due to global warming, but they could also be due to natural variability, that is, normal periodic upticks in chlorophyll due to nature weather-related phenomenon. An El Nino or La Nina event will throw up a very large change in chlorophyll because it's changing the amount of nutrients that are coming into the system, she says. And because of these big natural changes that happen every few years, it's hard to see if things are changing due to climate change if you're just looking at the chlorophyll. And then they had modeling ocean light. Instead of looking to derived estimates of chlorophyll, the team wondered whether they could see a clear signal of climate change's effect on photoplankton by looking at satellite measurements of reflected light only. The group tweaked a computer model that was used in the past to predict phytoplankton changes with rising temperatures and ocean acidification. This model takes information about phytoplankton, such as what they consume and how they grow, and incorporates this information into a physical model that simulates the ocean's currents and mixing. But this time around, the researchers added a new element to the model that has not been included in other ocean modeling techniques, and that is the ability to estimate the specific wavelengths of light that are absorbed and reflected by the ocean, depending on the amount and type of organisms in any given region. Sunlight will come into the ocean, and anything that's in the ocean will absorb it, like chlorophyll, she said. Other things will absorb or scatter it, like something with a hard shell. So it's a complicated process how light is reflected back out of the ocean to give it its color. The nice thing about this model, she said, we can use it as a laboratory, a place where we can experiment to see how our planet is going to change. Now, a signal in blues and greens. As the researchers cranked up global temperatures in the model up 3 degrees Celsius by the year 2010, what most scientists predict will occur under a business-as-usual scenario of relatively no action to reduce greenhouse gases, they found that wavelengths of light in the blue-green waveband responded the fastest. And what's more, Dukeshewitz observed that this blue-green waveband showed a very clear signal or a shift due specifically to climate change, taking place much earlier than what scientists have previously found when they looked to chlorophyll, which they projected would exhibit a climate-driven change by 2055. Now, according to their models, climate change is already changing the makeup of phytoplankton, and by extension the color of oceans, but by the end of the century, our blue planet may look visibly altered. Dukeshewitz said there will be a noticeable difference in the color of 50% of the ocean by the end of the 21st century. She said it could be potentially quite serious. Different types of phytoplankton absorb light differently, and if climate change shifts one community of phytoplankton to another, that will also change the types of food webs they can support. This research was supported in part by NASA and the Department of Energy, and I'll leave links below for you for this, from the MIT News. Please leave your comments, and thank you for your support.